Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. As a part of analysis of structures, today our topic is three-hinged arches. Here we are going to understand what are the various types of three-hinged arches, what is meant by three-hinged arch, what are the various types involved. So these are the various things which we are going to understand in this particular lecture. On which type of analysis of structure we are using these kind of three-hinged arches. So the name itself tells us three-hinged arch. Here we have three different hinges present in that particular arch. So this is the shape of the arch. In this, the ends having, whether it is maybe similar axis, sometimes it may not be similar, it depends upon the requirement of the arch. So here, based on the arch, and one more is present at crown. This is the arch. This is the hinge. One more is present in arch, like this. So these type of hinges present in arc, the number of hinges are 3. Such type of arches are known as three-hinged arches. So here we are introduced these three-hinged arch are structural element. This is the one of the element which we used for the construction of any in structures. So it is used, these kind of arches we are used for span long distance and support floors. For long spans we are using these kind of arches. Here they are widely where we are using these kind of arches are used in bridges, roof structures and large span bridges. So in large span bridges, these kind of arches are helpful for carrying those support loads. Here, three-hinged arch has hinges at 2 supports, whether it is maybe similar, same axis or maybe different axis. So here 2 supports usually denoted as points A and B, and one more additional hinge at crown. This is the height of the highest point of the arch is known as the crown, that is the point C. So these are nothing but the three-hinged arches. In these three-hinged arches, some structural characteristics are involved in arches. So same axis. So this is at A and B, at crown that is C. These are the hinges. So here, determinate whether the structure is statically determinate or indeterminate, it depends upon the equilibrium conditions. Equilibrium conditions. So, sum of the forces. What are the equilibrium equations? Sum of the all forces which are relevant to that particular element. Those are the sum of horizontal forces. Or in terms of x, we are calling here x-axis. So, the sum of horizontal force is equal to 0. This is the one of the equilibrium condition. And one more is the y-axis we consider vertical forces. Sum of all vertical forces which are involved in that particular structure is one of the equilibrium condition. And one more is the momentum. All movements, the sum of all movements is equal to 0. This is nothing but the static equilibrium conditions. So according to the equilibrium conditions, we are find out the unknowns present in that particular element. So within these, using these equilibrium equations are enough. Such type of structure is nothing but the statically determinate. Once these 3 equilibrium conditions are not enough for finding the unknowns which are present in that particular structural elements, such type is known as indeterminate structures. Additional equations are required. So in this, three hinged arches are known as statically determinate, means Equilibrium conditions are enough. 3 equilibrium conditions, static equilibrium conditions are enough for finding the unknowns. So, such type of structural element is known as the statically determinate. 3 hinged arches are belongs to statically determinate structures. And next characteristics is flexibility. So, due to the three hinges, one off at crown, so these 3 hinged arches more flexible and can accommodate settlements at the supports and temperatures changes without generating the significant internal stresses because of the one more hinge that is act at the center. So here it is more flexible one because of the it is going to accommodate the settlements at the supports. So whenever the settlements at the support and temperature changes also, because of these temperature changes and the settlements happened in the supports, they are increased their internal stresses. Internal stresses. Such type of characteristics are involved in these 3 hinged arches. Here, these are the 3 basic equilibrium equations we are used for solving the 3 hinged arches. That is, sum of the horizontal forces is equal to 0, and also sum of the vertical forces is equal to 0. Sum of the movement about any point in that particular element is equal to 0. These are nothing but the basic equilibrium conditions. These are enough for solving the 3 hinged arches. No need of any additional forces, additional equations. That is nothing but determinate structure is 3 hinged arch. So we are using these 3 things: sum of the horizontal forces, sum of the vertical forces, sum of the movements. Here all are we are considering x-axis and y-axis in this 3 hinged arch, whether it is maybe any condition like this. So here this x-axis, in x-axis and y-axis we are considering the forces. Any forces in between also we may resolve towards to y-axis or otherwise towards to x-axis. So like this, the many forces are like that, means we are going to resolve to them to x-axis as well as the y-axis. So we are using these equilibrium equations. So how we are derive these equations for determination of the internal forces in 3 hinged arch. So here we are consider this 3 hinged arch, and this is the point load is there, and this consider section at Q or X. In some of the situation they are considered it is X or Q. Here we are considering in terms of Q. In some of the textbooks it may X. We are cutting these section like this. And the internal forces at this section are axial force, that is nothing but the NQ, and also radial shear force VQ, and in the bending moment MQ are in terms of NX, that is the axial force, and the VX, that is the radial shear force. And M of X, that is equal to movement with respect to that axis, if we consider as X instead of Q. Movements in terms of X. So like this we are understanding the various parameters which are involved in this 3 hinged arch. So the derivation of these equations for the determination of the forces with respect to the angle. We are understanding with respect to angle, we are going to find out the here what we are going to find out is internal forces which are involved, and what is the load at point load, the load condition, point load, The cut section is Q. So this axis we are going to understand in this. Now, bending moment equation is equal to, with respect to the angle, we are understanding ay into x minus ax into y with respect to, and bending moment along the x-axis for that particular point Q. So these are the conditions which we are going to understand. So here this MB with respect to moment of the beam of the same span as an arch. Y is the ordinate of any point along the center line of the arch. Any line, center line of the arch. So here any central line of the arch at ordinate of any point. For this parabolic arch, y is equal to 4f of x. Y is equal to 4f of x by L square. L minus x. This is L is nothing but the span of the arch. And for this is for parabolic arch. Parabolic arch. And for similarly, y is equal to root radius. R is nothing but the radius of the arch. Arches of that particular curvature minus L by 2 minus x whole square. R plus F. Here, y is the ordinate of any point along the center line of the arch. F is equal to rise of the arch. And this is vertical distance from the center line to the arch crown. Here we are considered this is the F. This is the vertical line from C. So this is the vertical line and F is the rise of the arch. It is the vertical distance from the center line to the arch crown. So it is nothing but the midpoint from A to B. This is the midpoint to center of the arch or at C, crown point. And L is the span of the arch. R is the radius of, and here the radial shear force at Q. So the radial shear force at Q, these are the condition we can finally, this is the, for parabolic arch, this is the formula. For circular arch, this is the formula. So in this, the radial line we consider how we will get this is. So here we consider the radial line from the previous, from here to here. So here this is the angle. Understand this? So this is the radial line. Here that angle is nothing but AY sin phi, and from here to here, this is vertical. From here to here perpendicular to that, that is equal to AY cos phi. This is the angle theta and this is AY. This is the radial line. From here shear of the beam is equal to AY sin phi minus AX cos phi. So V at rate of beam sin phi minus AX cos phi. So here axial force at Q. Axial force at point Q. And finally, we are finding this axial force for this section NQ. This axial force is equal to AY minus AY cos pi minus AX sin pi is equal to minus V cos pi minus AX sin pi. So this is the radial force we are finding. Now, three-hinged arches, how we'll understand in terms of different considerations, these various support reactions, how we'll find? Well, it's better gives the example when compared to this. So now here a three-hinged arch is subjected to two component concentrated loads as shown in figure determine the support reactions of the arch. Here these two are not in the same axis. Observe the things. So not in the same axis. It is not a symmetrical one. It's not a symmetrical one. And this is the crownet. This is C. So these are the three ways, and the difference between these two. A here. This is that A. This is the arch. What we understand that is equal to. I will draw again once again. So here from A to A is starting point. Hinged. One hinged is here present here, and move on to the at load is acting, that is nothing but B, and at the center height of the cone, that is equal to C, and one more load is acting at D. Final hinge is at E. These are the various parts involved in this particular arch. Here the height difference between this A and E is 15 meters, and at B 15 kilonewtons point load is acting, and also from A to B, the horizontal distance is 5 meters. From B to C, the horizontal distance is 15 meters. And from A to C, that is equal to 20 meters. From C to D, that is equal to 20 meters. From D to E, that is equal to 5 meters. From C to D is equal to, that is equal to 25 meters. So this is the differences are there. Previously what we thought from here to here, this is the same distance is there. But here from A to C, the horizontal distance is 20 meters. From C to E, that is equal to 25 meters. And again at the point D, one more 35 kilonewtons point load is acting. So the load differences is also there. Here the 30 at point D, 35 kilonewtons point load is acting. At point B, 50 kilonewtons load is acting. So these are the things which are going to understand in this. From the height differences we will see in this picture here. So this is the free body diagrams of the entire arch and its segment CE as shown in figure both B and C. Here the free body diagram which we are going to draw from the given point, that is equal to vertical force, and also the horizontal force are acted at point A, and this is the 50 kilonewton load is acting at B, C, and also at D 35 kilonewtons is acting, and at E horizontal and vertical reactions are equal. This is the equilibrium conditions which we are going to draw. And from CE only, from we are cutting from CE only, we are understanding this is the upward force vertical, and this side horizontal C of X, and also the D at 35 kilonewtons, and E is there. So like this we are understanding, we are applying the static equilibrium equations. We have to write about the static equilibrium equations. Here the three hinged, the entire arch. So we are considering the complete arch, the entire arch we are considering. That means the positive in this direction we are considering moment at A is equal to 0. That is nothing but the overall length from here to here, that from here to here it is 20, from here to here it is, that is 25, from here to here total that is equal to 45 meters. So from here to here that is equal to 45 meters. From C to A is 10, from A to E is 15 is there. From A to E is 15, and D to E is 20, from D to C is 10. So like that from B also same. So like this we have to remember. From D to E is, from here to here it is 15, from here to here that is 20, from C to D is 10. These are the distances. Now we have to write about this momentum equation. To draw the figure here, we are considering the moments. This is the thing. So anti-clockwise is positive at the moments. Now we have to draw the free body diagram here for understanding the numerical values. A, B, C, DE. From here the load is 50 kilonewtons. At D that is equal to 35 kilonewtons. The horizontal distance between A and E is totally 45. From A to C is 20. From C to E is 25 meters. And the vertical distance from A E is equal to 50. And the vertical distance from AE is 50. The vertical distance from DE is equal to 20. And from D to C is 10 meters. So this is the diagram. I will draw very neatly. Here some disturbance is there. So it is not clear. So clearly we draw these the distances from where to where. This is the thing. From A to E. Horizontal vertical distance is 15 meters. This is A. This is B. This is C. And this is D. And this is E. From D to E, the horizontal distance is 20. From C to D is 10. From the horizontal distance from A to E is 40. From A to C is that is equal to 20 meters. From C to E is 15 meters. These are the things we have. At point B, 50 kilonewtons load is acting. At point D, 35 kilonewtons load is acting. So here considering the movements from A. So now here this is AX horizontal, this is AY, and this is EX, and this is EY. So now EY, the overall distance 20 plus 25, 45. So that is equal to EY. So that is EY multiplied by 45 minus EX, because it is in this direction, opposite direction. So that's why minus EX, this horizontal, this distance from like this. So that's why EX multiplied by 15 minus this is the 50 kilonewton. So from 50 to here to the distance is 5, because this is 20. From here to here that is 20. From here to here that is equal to 5. So 50 into 5 minus 35 into 40. This is equal to from here to here. This is 5 meters. That is there in this problem. So 35 into 40, that is equal to 0 as per the equation. So finally what we get? 45 EY minus 15 EX is equal to 1650 after calculations. Now complete the arc segment CE only. So consider the arc segment CE only. Complete the arc segment only CE movements at C. So now EY multiplied by from here to here, that is equal to 25 meters minus EX into 30 meters, because from 20 plus 10 from E to D, that is equal to 20 meters. From D to C is equal to 10 meters, that is equal to total 20 plus 10, 30 minus this load is 35 multiplied by this horizontal distance is 20. So from here that is equal to 35 multiplied by 20 is equal to 0. So after calculations, 25 EY minus 30 EX is equal to 700 when we consider the arch CE only. So this portion, whenever we consider, that gives the thing. Now, after solving these two equations, what are the equations? 45 EY minus 15X is equal to 650, 25 EY 30 into 700. So multiply this into 2 times. So 45 90 EY minus 30 EX. So 1652 into 1650 multiply like this, we will get the and add this. Finally, solving these equations, finally we will get EY is equal to 40 kilonewton upwards and EX is equal to 10 kilonewton. So for the entire arch, we are applying this. Now sigma f of y is equal to 0. Positive, consider upwards is positive. So this AY plus 40 minus 50 minus 35 is equal to 0. Finally, AY is equal to 45 kilonewtons upward. And consider the equations from horizontal, that is equal to sigma f of x is equal to 0. This is considered as this angle, this direction is positive. Now ax minus 10 is equal to 0. Ax is equal to 10 kilonewtons. This is the sign for ax. Like this, we are finding the ax, ay and ey and ex. These are the things we are going to find out according to the given problem. Now move on to the another kind of problem, that is a parabolic arch with supports at the same level. We understand in this particular problem, in previous problem, that is two different levels. Here within the same level. So A and B at crown is C. Here the distributed load is there. Here the point load is at there, that is equal to 50 kilonewtons from 8 meters distance to A. From A to C, that is equal to 20 meters, and also this is equal to 20 meters because at midpoint to here the crown height is there. So that is equal to 12 meters. From here to here, this one end is completely acted with the uniformly distributed load. That is equal to 4 kilonewton per meter square. These are the loads given in this. So determine the support reactions and also the normal thrust and radial shear at point just to left the 50 kilonewton concentrated load. This is the given data. Now move on to the support reactions. First, any kind of problem, first we have to draw the free body diagram is the first step we have to understand. Draw the free body diagram. So first here draw the for entire arch. For entire arch we are going to draw this. This is equal to AY upwards at point at A and AX at A and also with BX, BY. These are the things which are involved in this, and apply the static equilibrium equations to determine the reaction. So here draw the free body diagram from one side. This is the free body diagram we have to understand. So here at C, this is equal to Cx and this is equal to Cy. We are considering this left side portion, that's why we are understanding like this. Previous we consider the right hand side, so there the reactions are different. Any point that is equilibrium. So in somewhere it is acting 150 kilometer. From here to here, that is equal to 8. So as per the problem, just here to the one, that is 8. So like this we are considering. Now draw the moments. Here we are considering the moments with respect to A is equal to 0. So By, we are considering the entire arch for these calculations. By 40 minus 150 into 8 minus 4 into 20 into 30. It is uniformly distributed load. So By is equal to 90 kilonewton upwards. Similarly, sum of the all vertical forces, whenever the upward is considered as positive, that is equal to 0. So now Ay plus 90 minus 150 minus 4 into 20 is equal to 0. That is equal to Ay plus 90 minus 150, 80 is equal to 0. Now Ay plus 90 minus 230 is equal to 0. So Ay minus 140 is equal to 0. Ay is equal to 140. Here this is indicates the positive sign. So upwards. Here we consider positive in upward side. For sigma arch, we consider the arch at sigma AC. So here moments at C is equal to 0. So Ax multiplied by 12 minus 140 multiplied by 20 plus 150 multiplied by 12 is equal to 0. So now 12Ax minus 28 minus plus 150 multiplied by 12. So 150 multiplied by 12 is equal to 0. Finally, we will get, after the calculation, we will get 83.33 kilonewton. So that is equal to in terms of this side. So like that, we have to understand this is, it will get in negative. So that's why we are considering this one. So this is the This is the thing we are going to understand in after calculations we will get this. So like this we are going to understand the calculations of the movements. Now here entire arch we didn't get the remaining parameters also there. So f of x is equal to 0. 833.33 minus bx is equal to 0. Already we know the ax value. So here actual formula is ax minus bx is equal to 0. Here ax is equal to 83.33 minus bx is equal to 0. So bx is equal to positive 83.33. This is the direction inside positive side. Now normal thrust and radial shear. Here to determine the normal thrust and radial shear, find out the angle between the horizontal and the arc just left to the 150 kilonewton. So here we know the formula, that is equal to 4 pi x. It is the parabolic arch. So the formula is, we are applying the formula and substitute the values in that particular formula. X square. This is the formula. So this is equal to, we know the formula. So y is equal to 4f by L square, L minus x. After that we are going to tan theta is equal to y dash f of y L square, L minus 2x. So substitute all the equations. Finally we will get the angle. After knowing the angle, then only we are going to find out the normal thrust. So this is the formula for normal thrust. We substitute the formula. Normal thrust formula is equal to ay sin phi plus ax cos theta. We substitute the value. Finally we will get the normal thrust after calculations. And also the radial shear also we have the formula. Radial shear is equal to ay cos phi plus ax sin phi. Substitute the values. Finally we will get the radial shear value. Using the formulas we are finding the normal thrust as well as the radial shear. And consider one more, a parabolic arch is subjected to uniformly total. In previous what we understand, here also the within the same axis we are considering the both the ends, both the supports at the same. Here the parabolic arch is uniformly distributed load throughout. So determine the support reactions and the bending moment at Q in the arch, which is a distance of 8 feet from the left hand support. From here we are going to find out the things at this particular point. So here the support reactions, first we are going to draw the free body diagram. So applying the equilibrium equations we will get the thing. So here this is symmetry, that's why we are considering like this. This is the formula we are using for getting the free body before knowing about the free body diagram. Now draw the free body diagram considering the movements and also understand the what are the various things are involved in this. As per the diagram we are understanding the momentum with respect to A. So here Ey into 40 minus 50 into 8 minus 20 multiplied by 35 is equal to 0. After calculations we will get the vertical at point E. So for entire arch we are considering in this particular condition, and also all the horizontal forces is equal, all the vertical forces is equal to 0. The upward direction is considered as positive. We'll get the AY value and substitute. And arch segment EC, consider only arch segment EC. Draw the free body diagram for that, and consider the movement with respect to C. All movements with sum of the all movements with respect to C is equal to 0. Draw the equation and find out the equation using the diagram and find out the values after calculation. Consider again the entire arch. Find out the horizontal forces with respect to all the sum of the horizontal forces is equal to 0. So write down the equation, we will get the required thing. So after that, the bending moment at locations they are mentioned. So that is for using this normal thrust. Here it is also again it is a parabolic arch. For that, this is the formula at where they asked about that. In that particular, we are finding the equation. According to that, we will get the where the height is there. So like that, we are understanding and draw the bending moment equations. And now this is the thing we are having. Determine the what are the various how we are going to determine. So using the bending moment equations, like that, we are understanding the diagrams we are going to draw in terms of thing. So these are the various fabric resources we are using for better understanding about the three-hinged arches. Here what we understand in this particular three-hinged arches, finally, three-hinged arches are statically determined structures. Statically determined structures, and these three-hinged arches are flexible. Using statical equilibrium equations are enough. For getting the results. So these are the things we are going to understand in this particular three-hinged arches. So these are the references. They are helpful for better understanding about the three-hinged arches. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.